All right, friendos, here we go. Data management, our new math unit. So, our learning goals for this unit, and most likely for this week, is that we want to interpret and evaluate data in tables and graphs and draw labeled graphs by hand and with a computer. Now, this week we're going to be learning how to use a computer to make a graph using Google Sheets. But before we can do that, we need to look at the different kinds of graphs we can make so that we know when to use what. So, first one, we've got a circle graph, which is a bar chart, also known as. So when we have a circle graph, we need to have a set of data that totals up to 100%. So we are showing parts of a whole. Now, that means that we cannot use a pie graph if we are trying to show data that can have an unlimited number of data points. It means that we need to use it when we know we're representing the whole with these chunks. So here, if we ask the class, what's your favorite pie? That would work because we are only ever going to have 23 kids that we are surveying. And remember, a survey is when we ask people for our data. So another example would be if we surveyed the whole school and asked who did sports outside of school, who did music outside of school, who did both, and who did none. That would be an example because there's a finite number of students in the school to survey. Finite means there's a number. We have that number and we can't go past it. Next up, we have the bar graph, which is one of the most used ones that you guys will be aware of. But it's also one of the ones that's the most misused because we just tend to use a bar graph when we don't know what to use. But for a bar graph, we are comparing sets of data. So, for example, if you look at the bar graphs here, we're comparing something to do with what happens in the months. So it could be the amount of rain that we've got. It could be how warm it was. It could be a lot of different things. But basically, we're comparing different separate numbers. So they're not part of a whole, they're just each individually shown. So another example that we could use that for would be if we wanted to show the ages of people in the classroom, if we wanted to show the number of people who have a birthday on a certain month, that kind of thing. Next up, we have a pictograph, which is one that you used a lot when you were a kid. And we don't use it so much anymore, not that you guys are older, but you will see them. A lot of stores use them for showing different incentive programs and stuff like that. So you'll still see them. And basically, it shows a picture that represents a certain thing. So in this case, the smiley face represents a math score of over 80%. So Ted has had that twice, so he has 2 smiley faces. Sally has had it 3 times, etc., etc. Broken line graph. So a broken line graph shows data points, and then you join them together by a line where each segment shows trends over time. So you're drawing a straight line between each of the dots, and it shows you, is it an increase? Is it a decrease? Did it stay the same? That's what we're using a broken line graph for. So usually it's the when we're comparing to see if there was a difference in time. Next up, we have a continuous line graph. So this is where points are plotted on a line between the starting point and the ending point. We like to call this the line of best fit sometimes when it's perfectly on all the dots. Sometimes it also will not be on all the dots, but we'll still call it the line of best fit. You'll notice that the independent variable is on the x-axis, and an independent variable, reminder, that means that it does not change. And a dependent variable is on the y-axis, which is here, and that's the thing that will change all the time. Okay? So if we move on, we'll go more into independent and dependent variables later on in this unit. Scatter plots are basically a line graph, but you aren't going to join the lines together. So it's just showing a bunch of different data to see if there's a correlation, which means is there a relationship. So you'll see here that if the number gets higher here, the number gets higher here. So that has a correlation. But if it just looks like a bunch of random dots, there's no correlation, no relationship. All right, so we're not going to worry about the sample questions today, but those are our different kinds of graphs. I'm going to do a separate video showing you how to do it on Google Sheets. So jump back in on